Hey, so lesson 3.2 is all about multiplying polynomials. So a brief example before I show you what the problem set looks like. When you multiply polynomials, it's similar to FOIL if it's a smaller polynomial. So x plus 1 times 3x plus 5. In this case, it's just FOIL, right? So that's 3x squared, easy enough. That is going to be 5x. This is going to be 3x, and the last one's going to be 5. And then, of course, you combine like terms. However, we're going to do it using the box method, and the reason for that is because of some things we'll do afterwards, like in lesson 3.3 and beyond. So that would mean that I have x plus 1 along one side of the box, and then I have 3x plus 5 along another side of the box. And then these coordinating squares are what it becomes. So I just multiply x by 3x to get 3x squared. Then I multiply x by 5, which becomes 5x. Then I multiply 3x by 1, which gives me 3x. And then I multiply 1 by 5, which gives me 5. So you can see I have the same terms as I did originally. 3x squared, 5x, 3x, and 5. But you notice that these diagonals line up as the same terms. These are the same terms. And so that allows me to say, well, if I take everything across this diagonal, right, and combine it, that it ends up being 8x, right? And that can simplify to my final answer, just like I would combine terms here to get 8x. So the box and FOIL are the exact same, plus 8x plus 5, and they both provide us with the same solution. Similarly, if we have larger polynomials like 3x squared plus 2x plus 1, and we're going to multiply it by 5x squared plus x plus 3, we can also use that by setting up a box method. So we have 3x squared plus 2x plus 1 across the top of the box. Then we have 5x squared, x, and 3 down the sides. And this creates our box for us. And we can begin to multiply terms. So again, 5x squared times 3x squared becomes 15x to the fourth. You can notice here that I am actually multiplying these coefficients to get my new coefficient. And then I'm adding these exponents to get my exponent. So if I continue on, 5x squared times 2x cubed, multiply 5 times 2 is 10. Add 2 plus this invisible 1 that's up here, and that gives me 3. 5x squared times 1 is 5x squared. 3x squared times x is 3x cubed. 2x times x is 2x squared. X times 1 is x. Down to the last line. 3 times 3x cubed, 3 times 3x squared is 9x squared. 3 times 2x is 6x. 3 times 1 is 3. Then I can go ahead and I can begin to identify each of these diagonals. So this particular diagonal here in yellow is my x cubed diagonal. These are all the x cubed terms. Then in orange, I have my x squared terms. In green, I have my x terms. And you can see that these are forming diagonals. So this particular diagonal can sum up to 6x plus x, which is 7x, right? This particular diagonal, this orange diagonal, if I sum them up, 9, 10, 11, 16. So this is 16x squared. This yellow diagonal, if I sum them up, becomes 13x cubed. The same thing would be true with this top box, which is its own diagonal. That's our only x to the fourth term. And this bottom box is our only This bottom box over here, sorry for the confusion, the bottom box over here is the only box, it's 3. So each of these terms represents our answer. So the answer would be 15x to the 4th plus 13x cubed plus 16x squared plus 7x plus 3. So that's the basic idea behind multiplying polynomials. Now we're going to jump on our problem set. And the problem set's unique because in the problem set, we give you the answer. So here's a typical question that you're going to see in the problem set. I went and skipped to a slightly different problem just to give you a better perspective for the first one that we do. So here's what it's going to look like. F of x is equal to 4x squared plus 7x plus a. This will always be some polynomial. And g of x is equal to bx plus 2. This will be the polynomials being multiplied by. And h of x, and you can see down here, h of x is the solution, is equal to 12x cubed plus 29x squared plus 5x minus 6. So you can see that all it wants us to find is a and b. It doesn't want us to find the entire answer. It's giving us the answer. It just wants us to find what a, which is right here, and what b, which is right here, what those numbers actually are. And the way that you find this is by multiplying. So I will set up the box method one more time that you've already seen twice. So I have 4x squared plus 7x plus a across the top. And then I have bx plus 2 down the side. And then I can begin to multiply. Bx times 4x squared, well, that's 4x cubed, and then there's the b. 7x times bx, that's 7x squared, then there's the b. Bx times a is bx a. 4x times 2 is 8x squared. 2 times 7 is 14x. 2 times a is 2a. So we filled out the box, and now I'm going to highlight the diagonals. So this 4x cubed b is the only term there, so I'll start here. Here's a x squared diagonal. So these are all the x squared terms. Then we have an x diagonal, so each of these terms on this diagonal are the x's. And then, of course, as I've kind of already mentioned, this single box represents all the constants, and this single box up here represents all of the cubes. So our answer here is already given. It's already given up here. So I can say, well, this represents all the cubes. 4x cubed times b represents all the cubes. What are all the cubes? All the cubes are 12x cubed. I know that because h of x is my answer. This is the answer right here. So if this is true, and I simply solve for b by dividing by 4x cubed, x cubed divided by x cubed is 1, which is the multiplicative identity, so I don't need that. 4 divided by 4 is 1, which is the multiplicative identity, so this becomes b. And it's equal to 12 divided by 4, which is 3. Well, that makes sense. 4x cubed times 3 is 12x cubed, which equals my answer. So I know that b is going to be 3. Similarly, if I'm over here with the 2a, I know that all of my constants have to become -6. So I can say, well, -6 is the same thing as 2a. I can solve for a by dividing by 2, and -3 is equal to a because 2 divided by 2 is the multiplicative identity. It's 1. So a is -3. Let's do another example. Here we have two polynomials, but each of them have 3 terms. 8x squared ax minus 7, bx squared plus 4x minus 7, and then we have this longer answer. So we will solve for this the same way using the box method. So we have 8x squared plus ax minus 7. And then we have bx squared plus 4x minus 7. completes our box. Now we can multiply through. So this is 8x to the 4th b. This is abx cubed. This is negative 7x squared b. This is 32x cubed, 4x squared a, negative 28x, negative 56x squared, negative 7xa, and negative 49. So we see here that we have these diagonals again, a cube diagonal, a square diagonal, an x diagonal. Then we have an x to the 4th by itself, and we have negative 49 by itself. You can see that the negative 49, this should be a positive 49, silly me, and this positive 49 match. So again, negative 7 times negative 7 is positive 49. These two things match, which should happen because, again, this is the answer. It's giving us the answer. Okay. Now I will highlight my diagonals, and we will go from there. So each of these diagonals has been highlighted to identify what their like terms are. If I take these blue diagonals, those should combine to my x term. Well, what is my x term? My x term is negative 49. Those should combine to negative 49x, right? We have this a that throws it off, but we'll come back to that. This green diagonal will add up to negative 72x squared. So the green diagonal is negative 72x squared. This yellow diagonal will sum up to 44x cubed. And this top diagonal should sum up to 32x to the 4th. Okay? So the blue has just an a. We could solve that. The green has an a and a b. We can't do that. The yellow has an a and a b. We can't do that. And the top one has just a b. So if I want to solve for b, then the easiest way to do it is using that top diagonal. So I know that 8x to the 4th times b should equal 32x to the 4th. To solve for b, I divide by 8x to the 4th on both sides. That's the division property of equality. And 8x to the 4th divided by 8x to the 4th is 1, which is the multiplicative identity. X to the 4th divided by x to the 4th on this side cancels to 1. I'm left with 32 divided by 8, which is 4. So b is going to be equal to 4. Now I can either use the blue diagonal to solve for a, or I can use any of the other diagonals to solve for a. Here's an example of using the yellow diagonal to solve for a. 44x cubed is equal to 32x cubed plus a, which we don't know, times b, which is 4x cubed. So I can use inverse operations, the subtraction property of equality, to subtract 32x cubed. 44 minus 32 is 12x cubed, and that equals a times 4x cubed. So I'll write that over here to have more space. 12x cubed equals a times 4x cubed. I can divide by 4x cubed to solve for a. 4x cubed divided by 4x cubed is 1, which is the multiplicative identity, so I have 1a. And that is equal to 12x cubed divided by 4x cubed. The x cubes are 1. 12 divided by 4 is 3. So what does a equal? A equals 3. So now you have the concepts and you have a couple of examples of the homework. Good luck.